Let's delve into the realm of electrical concepts, focusing on understanding and interpreting visual representations of these principles. Electricity is a fundamental force of nature, and its behavior can be described through various parameters such as voltage, current, and resistance. Voltage, often described as electrical potential difference, is the driving force that pushes electrons through a circuit. It is measured in volts. Current, on the other hand, is the flow of electric charge, specifically the movement of electrons through a conductor. Current is measured in amps. Resistance is the opposition to the flow of current within a circuit, and it is measured in ohms. These three parameters are interconnected through a fundamental relationship known as Ohm's law. Ohm's law states that voltage equals current multiplied by resistance, or volts equals amps times ohms. This relationship is crucial for analyzing and designing electrical circuits. A circuit is a closed loop that allows current to flow continuously. Circuits typically consist of a voltage source, conductors, and one or more components that consume electrical energy, such as resistors, capacitors, and inductors. Resistors are components that provide a specific amount of resistance to the flow of current. Capacitors store electrical energy in an electric field, while inductors store energy in a magnetic field. When analyzing circuits, it is often helpful to use circuit diagrams. Circuit diagrams are simplified representations of electrical circuits that use symbols to represent different components. For example, a resistor is typically represented by a zigzag line, a capacitor by two parallel lines, and an inductor by a coil. A voltage source is represented by a circle with a plus sign on one side and a minus sign on the other. By understanding these symbols, one can interpret circuit diagrams and analyze the behavior of the circuit. In addition to Ohm's law, there are other important concepts in electrical theory. One such concept is power. Electrical power is the rate at which electrical energy is transferred or consumed in a circuit. It is measured in watts. Power equals voltage multiplied by current, or watts equals volts times amps. This relationship is important for determining the power rating of components in a circuit and for calculating the overall power consumption of the circuit. Another important concept is series and parallel circuits. In a series circuit, components are connected end to end so that the same current flows through each component. The total resistance of a series circuit is the sum of the individual resistances. In a parallel circuit, components are connected side by side so that the voltage across each component is the same. The reciprocal of the total resistance of a parallel circuit is equal to the sum of the reciprocals of the individual resistances. Understanding the difference between series and parallel circuits is essential for analyzing and designing more complex circuits. Furthermore, electrical safety is of utmost importance. Working with electricity can be dangerous if proper precautions are not taken. It is crucial to understand the potential hazards associated with electricity and to follow safe work practices. Always to energize circuits before working on them, and use appropriate personal protective equipment such as insulated gloves and safety glasses. Grounding is another important safety concept. Grounding provides a low resistance path for fault current to flow back to the source, which helps to protect people from electric shock. Electrical codes and standards, such as the National Electrical Code or NEC, provide detailed requirements for electrical installations to ensure safety. It is essential to comply with these codes and standards when working with electricity. Moreover, alternating current, or AC, and direct current, or DC, are two fundamentally different types of electrical current. Direct current flows in one direction only, while alternating current periodically reverses direction. In AC circuits, the voltage and current vary sinusoidally with time. The frequency of AC power is typically 60 Hz in North America and 50 Hz in Europe. Understanding the characteristics of AC and DC circuits is crucial for analyzing and designing electrical systems. Transformers are used to step up or step down AC voltage levels. A transformer consists of two or more coils of wire wound around a common core. The ratio of the number of turns in the primary coil to the number of turns in the secondary coil determines the voltage transformation ratio. Transformers are widely used in power distribution systems to efficiently transmit electricity over long distances. Furthermore, digital electronics relies on binary logic, which uses two states to represent information, typically 0 and 1. Transistors are the fundamental building blocks of digital circuits. A transistor can act as a switch or an amplifier, and it is used to implement logic gates such as AND, OR, and NOT gates. By combining these logic gates, one can create complex digital circuits that perform a wide variety of functions. Microcontrollers are small, self-contained computers that are used to control electronic devices. A microcontroller typically includes a processor, memory, and input/output peripherals. Microcontrollers are widely used in embedded systems such as appliances, automobiles, and industrial equipment. Understanding the principles of digital electronics is essential for designing and programming these systems. The NEC, or National Electrical Code, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It provides comprehensive guidelines for electrical installations, covering topics such as wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect changes in technology and best practices. Electrical engineers, electricians, and inspectors use the NEC to ensure that electrical installations are safe and compliant with regulations. NEC Table 310.15b16, or formerly NEC Table 310.16, provides ampacity ratings for conductors based on their insulation type and ambient temperature. Ampacity is the maximum current that a conductor can carry continuously without exceeding its temperature rating. It is important to select conductors with adequate ampacity to prevent overheating and potential fire hazards. The NEC provides detailed requirements for overcurrent protection, which is designed to protect electrical circuits from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are used to interrupt the flow of current when it exceeds a safe level. The NEC specifies the maximum allowable overcurrent protection for different types of circuits and equipment. Grounding is an essential safety measure that provides a low impedance path for fault current to flow back to the source. Grounding helps to prevent electric shock and minimizes the risk of electrical fires. The NEC provides detailed requirements for grounding electrical systems, including the use of grounding electrodes, grounding conductors, and equipment grounding conductors. Arc fault circuit interrupters, or SIs, are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. SIs are required in many residential circuits to protect against arc faults. The NEC specifies the locations where SIs are required. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock by detecting ground faults. GFCIs are required in wet locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electric shock. The NEC specifies the locations where GFCIs are required. Surge protective devices, or SPDs, are used to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power grid switching. SPD divert excess voltage away from sensitive equipment, preventing damage. The NEC provides requirements for the installation of SPD. Electrical permits are typically required for electrical installations to ensure that the work is performed in accordance with the NEC and local regulations. Electrical permits are obtained from the local building department. Electrical inspections are conducted by qualified inspectors to verify that electrical installations are safe and compliant with the NEC and local regulations. Passing an electrical inspection is required before an electrical installation can be put into service. Moreover, electrical drawings, also known as electrical plans or electrical schematics, are technical drawings that illustrate the layout and components of an electrical system. They are used by electrical contractors, engineers, and inspectors to install, maintain, and troubleshoot electrical systems. Electrical drawings typically include information such as the location of electrical outlets, lighting fixtures, and equipment, as well as the wiring diagrams and circuit schedules. Understanding how to read and interpret electrical drawings is essential for anyone working in the electrical field. There are various types of electrical drawings, each serving a specific purpose. Single-line diagrams are simplified representations of electrical systems that show the major components and their connections. Wiser diagrams illustrate the vertical pathways of electrical wiring in a building. Panel schedules list the circuits and loads connected to each electrical panel. Control schematics show the wiring and components of control systems. Electrical symbols are standardized symbols used in electrical drawings to represent different electrical components and devices. These symbols are defined by organizations such as the Institute of Electrical and Electronics Engineers, or IE, and the National Electrical Manufacturers Association, or NEMA. Common electrical symbols include those for resistors, capacitors, inductors, transformers, switches, outlets, and lighting fixtures. Understanding these symbols is essential for interpreting electrical drawings accurately. Wiring diagrams show the connections between electrical components and devices. They typically use lines to represent wires and symbols to represent the components. Wiring diagrams may also include color codes to indicate the type and function of each wire. Understanding wiring diagrams is crucial for troubleshooting electrical problems and making repairs. Circuit schedules are tables that list the circuits in an electrical panel and the loads connected to each circuit. They typically include information such as the circuit number, the type of load, the wattage of the load, and the wire size. Circuit schedules are used to balance the load in the electrical system and to ensure that the circuits are not overloaded. Electrical drawings are typically created using computer-aided design, or CAD software. CAD software allows engineers and drafters to create accurate and detailed electrical drawings. Some popular CAD software programs for electrical drawings include AutoCAD Electrical, Revit, and Eplan Electric Paint. These programs provide libraries of electrical symbols and tools for creating wiring diagrams and circuit schedules. When creating electrical drawings, it is important to follow industry standards and best practices. This includes using standardized symbols, maintaining consistent line weights, and providing clear and concise labeling. It is also important to ensure that the drawings are accurate and up-to-date. Electrical drawings are essential for communication between different parties involved in an electrical project. They provide a common reference point for electrical contractors, engineers, inspectors, and building owners. By using clear and accurate electrical drawings, it is possible to avoid misunderstandings and ensure that the electrical system is installed correctly and safely. Furthermore, consider the concept of voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Voltage drop can affect the performance of electrical equipment, especially in long circuits. The NEC provides guidelines for limiting voltage drop in electrical circuits. To calculate voltage drop, you can use Ohm's law, which states that voltage equals current times resistance. The voltage drop is equal to the current flowing through the conductor multiplied by the resistance of the conductor. The resistance of a conductor depends on its material, length, and cross-sectional area. The NEC provides tables that list the resistance of different types of conductors. There are several ways to reduce voltage drop in electrical circuits. One way is to use larger conductors, which have lower resistance. Another way is to shorten the length of the circuit. You can also use multiple parallel conductors to reduce the current flowing through each conductor. The NEC provides guidelines for sizing conductors to limit voltage drop to acceptable levels. Understanding and managing voltage drop is essential for ensuring the proper performance of electrical equipment and systems. Remember to consider the impact of harmonics on electrical systems. Harmonics are distortions of the sinusoidal waveform of alternating current. Harmonics can be caused by nonlinear loads, such as electronic devices and variable frequency drives. Harmonics can cause a variety of problems in electrical systems, including overheating of equipment, increased energy consumption, and interference with communication systems. To mitigate the effects of harmonics, you can use harmonic filters. Harmonic filters are designed to reduce the amplitude of harmonic currents and voltages. There are several types of harmonic filters, including passive filters and active filters. Passive filters consist of capacitors and inductors that are tuned to specific harmonic frequencies. Active filters use electronic components to actively cancel out harmonic currents and voltages. The selection of the appropriate type of harmonic filter depends on the characteristics of the harmonic distortion and the requirements of the electrical system. Understanding and mitigating harmonics is essential for maintaining the reliability and efficiency of electrical systems.